6.
Yeah, you have 6. Okay. Please get your calculator close to you. Okay, so we get 6. So you put the 6 also here. Eh? So it means the square root of n. That is what is around here. Eh? So that is why we are getting 20 over what? Over 6. Are you okay now? Eugene, are you okay? Eugene, your feedback. Oh, are you okay now?
I'm okay. I'm okay.
Very good.
I'm okay.
Okay, that's fine. Any other question? Any other question, please? Any other question? Okay. So if there are no questions, then go and read the probability less than 1.50 for me. Okay, so go and read probability less than. If the network is disturbing you, type it for us. Okay, Akko for Michael. Now, before I take your questions, let me just start on this again because I wasn't recording. So we're finding Z less than 1.5. What you do is you first find the reading to one decimal place, which is red on the first column here. So that is 1.5. And then you read the second decimal place, which is 0.00 here. And then you read along this row and this column where they intersect gives you the probability we are looking for. Okay. So, but don't forget that is just this probability here we have read. Okay. So if we want the final answer, we'll have to, let me go back to that page. So if we want the final answer, that is going to be 1 minus this probability we just found. Okay. So this is 1 minus 0.933193. Okay, which should give me the final answer. Yeah, I'm waiting for your response. 0.06. Okay. Somebody is asking, we have 1.5. So why do we look at the 0.00 column? I said in class that on the table, you read to 2 decimal places. So even if you get the answer to be Z is less than 1, just make it 0.00 and use that to read from the table. That is what we said in class. Okay. So if you have 1.5, because you need 2 decimal places, just add 0. Doesn't change anything. 1 and 1.00 doesn't change anything. It's still the same 1. 1.50 is still the same as 1.5. Okay, so it's just a matter of adding 0 to help you to read the table. That is all. I hope I've answered your question for you. Who was that? So, Engineer Asamoah. Okay, good. That's okay. Then I think I have Dennis. Dennis, your hand is up. So go ahead with your question. Dennis, your hand is up. Okay, let me take. Dennis is not speaking. Let me take Bismarck. Bismarck, I've unmuted you.
Sir.
Yeah, Dennis.
So I'm speaking. I said my question is: Are we using the normal standard distribution, or are we using cumulative normal standard distribution table? Which of them are we using?
The table you are having is a cumulative table, but it's called a standard normal table.
Hello, sir.
Yes. Then it's
So that's what I download on the net. So the figure I give you, that's the table I have. That's the figure, sir.
Then there is no difference. The standard normal table is a cumulative probability table. So whether you downloaded cumulative probability standard normal table, it will be the same. Okay.
No, sir. I have the table. I can come and show it to you on when we meet face to face. That's which is a normal standard table. But what I saw your own is a cumulative normal standard distribution table. Okay. Your own is cumulative, the normal standard distribution. But mine is not cumulative. Mine is normal standard distribution table. That's why I.
Are you by your computer or
say my figure is wrong? My answer I give it is wrong, and that's why I'm.
Okay.
I'm using my phone, sir.
You're using okay. I get you. So maybe the area, okay, on the left has been deducted from the probability. Okay, so when you come next week, I'll explain to you how it is read.
Okay, sir.
Yeah, that's fine.
Okay, sir. Thank you.
You're welcome. Yeah, so that is how we get the probability, the solution to this problem. Now, let's move on. So this is the solution. I think is really, depicted. We've already explained all of these, okay? So we'll move on. There's a second example here. It says X is normally distributed with a mean of what? 400 and a variance of 16. Determine the probability that an object selected. No, this is the first type, the one we're doing last week, because here we don't have sample, okay, mean the sample size here, okay? So let's keep, we have a lot of examples in hypothesis testing. So let's keep and go to hypothesis testing first. Then we'll come back to what we just did. Now, when we talk about inferences, now we are coming to start a proper statistical inference. Okay, when we talk about inferences, there are two techniques of doing that. We have methods of estimations. Okay, when we say method of estimation, we mean we are doing some calculations, okay, just to make a guess about the actual value in the population. So let's say I want a Benz car to purchase, okay. I'm not aware of the true price of Benz on the market, but what I can do is I'm going to find out from about 15 friends or 5 friends of mine who have that particular Benz car. and find out how much they bought it for. Okay. So once I pick that data, the data becomes sample data. Okay. So if 5 friends, I have 5 friends, X1, X2, X3, X4, and then what? X5. So my 5 friends will give me their prices. And then based on that, I will find the sample mean. Okay. The sample mean will give me. So if from the prices they gave me, that Benz car is around 90,000, okay, or 100,000 Ghana cedi. Okay. I can base on this estimates, this estimation here, okay, to say that approximately the true price of Benz when I'm going to the market is going to be around what, 90,000. Okay. And so we can have 90,000 here. Good. Very good. So whilst I'm going to the car shop, I may pick something around 90,000. Okay. Then somebody else may decide to, instead of picking exactly 90,000, will decide based on this to pick 90,000, okay, but plus or minus what? Some amount. Okay. So he may add some 10,000. Okay. And then once I get to the car dealer or the car shop or the garage, okay, I may negotiate. I may negotiate and get a price of around 80,000, okay, to 100,000, okay. We want to negotiate. Usually when you negotiate, you want to beat the price down, okay. But whilst you are going to the garage, you know that it's likely the price might have shot up a bit. So you have an estimate within 80,000 to 100,000. Okay, good. So that is under methods of estimation. Now, these methods I have just explained, you see, are based on the sample. First, you get sample data prices from your friends, and then you find the mean. Then based on the mean, you make a decision. Now, the person who decided to use just one sample point or one estimate to estimate the price of the true population value is doing what we call as a point, okay, okay, estimator. So we are doing point. Yeah, so like I was saying, the one who decided to use a single value of 90,000 is doing what we call as point estimation. Okay, point estimation. Whereas the other person who put some additional 10,000 and intends negotiating. Okay, so let me just put the value there. And then the one who was going for 80,000 to 100,000, okay, is doing what we call as interval estimation. Okay, we'll be looking at that in details later on. So this is interval estimation. So estimation techniques can either be based on what, a point estimation technique or an interval estimation. So we'll throw more light on that later. But for now, our focus will be on what we call as hypothesis testing. Okay. Now the question then is, what is hypothesis testing? Okay. So when we talk about a hypothesis testing, first we need to understand what we mean by a hypothesis. Okay. A hypothesis is a statement. It's a verbal claim about a population what parameter. So for example, Vortic mineral water may claim that their bottled water they produce, okay, is exactly what, 2.5 liters. Okay, that is a claim. But as to whether this claim when they made a claim to, the claim is on all such bottles they produce globally. Okay, the claim is on all such, okay, products which they are producing. So it means that it is population. That is why we say it's a population what parameter. So it's a population parameter. So when they made a claim on the app, they are talking about the average volume of all 2.5 liters bottle of water they produce. It's exactly 2.5 liters. Good. The same way when we take a battery, sometimes the battery manufacturer could give you, okay, the average life or the charges of the battery. So what the manufacturer is saying is, for all such batteries produced globally, okay, that is the average what? Average charge of that what? Battery, okay? The same way when you take your phone batteries, they give you some, okay, some, parameters or some values regarding the charge level of your battery. It's for all such batteries produced globally. So we say it's a claim about a population what parameter. Like we said, population parameter, it relates to all data on all what observations in the population. Good. Now, when we make a claim that is made by some of the manufacturers maybe false. Okay. Sometimes some manufacturers may make a claim, but in actual fact, when you buy their product, it's not so. Within a short time, you realize that these batteries, okay, fall short of standards. And even though they are telling you it's going to last for about 5 years, within a space of 4 months, that battery begins to what? Die off, okay? You see it's just, increasing in size, meaning it's just getting spoiled. I've encountered a scenario like that. So what we do in reality is, or to test these claims, is to, okay, Lawrence, I'm not going to mention any brand's name. So what we do in testing these claims is to sample. So we select, and so out of the batteries produced globally for that particular brand, we may select about 50 of those batteries here in Ghana randomly. Okay, we'll select 50 of the batteries and then conduct an experiment to check how long they are going to what? They are going to last. Okay, then based on the average information or the information we are gathering from our sample, we can make a deduction on their claim. So they may have been claiming that the average lifespan is for everything, for all the batteries is 5 years. Okay, but you will find your sample data and based on the sample information, you may find out that the average is about 4.5 years or something. Okay, the average is 4.5 years. Okay, with some kind of standard deviation or so based on your sample information, you want to test, you compare with theoretical distribution and test if the population claim is indeed true or false. Okay, so we say that hypothesis testing is a process that uses sample statistics to test a claim about the value of a population board parameter. Okay, now moving on. Moving on, we have some examples here. So it says an example will be a manufacturer claims that its rechargeable batteries have an average life greater than what? 1,000 charges. Okay, a random sample of 10 batteries has a mean life of 1,200 charges and a standard deviation of 14. Is there enough evidence to support the claim? Okay, so there has been a claim by a manufacturer. Then the researcher goes on to sample 10 batteries, okay, and then measures the average life. A random sample of 10 batteries. measures the average life, okay, and the standard deviation. Then based on that, he makes deductions on what? On the entire population. Another example is the farmer claims that this new malaria treatments will cure patients in less than 5 days. A random sample of 5 people who took medication shows an average of 4.8 days. Is there enough evidence to support a claim by the manufacturer? Okay, so these are questions related to what? Hypothesis testing. Okay, good. Okay. Okay, very good. So let's proceed from there. Yeah. So we now want to look at the steps. Okay, every hypothesis testing take. Okay, and from your end, I want you to write down the steps. Just take note of the steps. So write it down before we continue. So take some time and write down the steps in hypothesis testing procedure. Yeah, I believe you are done with what I asked you to write. So basically, there are 5 clear steps, okay, before we arrive at a decision, okay. But in computation, usually we do the step 5 and step 3, okay, together. Step 5 and step 3, you'll see us working on the 2, okay, together. Okay, just after identifying the test statistics, we use the information on the sample, okay, to calculate the value of the test statistic. Then we formulate the decision rule to arrive at a decision. Okay, so let's continue. Oh, Joseph says he has not finished writing. Please be quick. Let me move on. Princess outside like okay. Yeah, very well. So by now everybody should be done. So let me move on. Yeah. Okay. So we want to take each step, okay, and then explain the various steps and see how this whole thing works out, okay, in an example. So let's look at the step one. Step one says you have to state the null and alternative hypothesis. In every research, you have two types of hypothesis you conduct. We have the null, and then you have the alternate, or what we refer to as the research hypothesis. Okay, good. And because in your experiment, you see, you are conducting an experiment. Okay, so you are going for samples. You are going for samples to make a deduction about the population. You understand? So whenever we are making a hypothesis, okay, we first start from a point. What we do is you have to write the claim which has been made, okay, or the claim you've been asked to test. So for example, the manufacturer claims that its rechargeable batteries have an average life greater than what? 1,000 charges. This is the claim made by the manufacturer. And because that is the claim, and you are interested in finding out whether the claim is what? True or false, it becomes a research for you. Okay. Yeah, so like I was saying, because the manufacturer has made a claim and you intend checking or testing if this claim is true or false, that is your objective in your research. To test that what? To test that the claim by the manufacturer is what? Is true. That becomes your objective for your research. Now, in writing out the hypothesis, okay, in a mathematical form like we have here, what you do is first, you have to translate the given statement, okay, in a mathematical form, okay, in the sense that, for example, you say, we are saying that manufacturer claims that its rechargeable batteries have an average life. Now, this average is on the population batteries, because the batteries the manufacturer is talking about is on all batteries he produces, or he or that company produces. So that will be the population mean, the population average, okay? And then again, this manufacturer is saying that the population average is greater than, so we say the population average is greater than what? 1,000 charges. Okay, that is the claim being made. So if the average of the population is greater than 1,000 charges. Now, since we are testing to determine if this statement is true or false, if it is true, then this is the statement. But if it is false, then it will be a contrary statement, right? And the contrary statement to greater than will be what? Less than or equal to. Okay, so if it's not greater than, then it may be equal to, or it may be less than. Okay, so that will be, it's less than 1,000 what charges. So first you write it in the mathematical form, okay, convert it in the mathematical form, the given statement in mathematical form. Then the next thing is you find the contrary statement to the given statements. Good, because when you conduct your experiment, it may be true that what they are saying is true or is false. So if it is false, then what will be the false statement? Okay, so the false statement is going to be mu is not equal to, is less than or equal to 1000 watt charges. Then the next thing is you have to identify your null hypothesis. We write H naught, A subscript naught, we call it the null hypothesis. Null simply means zero, okay? So in other words, what we are saying is what exists is what we are finding, so it is null, okay? So it always has an equal to sign. So any statement that has an equal to sign, after writing in the mathematical form, okay, and the contrary statement, the statement that has the equal to, which is this statement here, okay, let me use another indicator, which is this statement here, okay, is a null hypothesis. So we write H naught, okay, such that mu is less than 1000 watt charges. Then the statement that does not contain an equal to is the alternate hypothesis, okay, which is written as H subscript A, not HA, H with a subscript of what? A. So we call that the alternate what? Alternate hypothesis. So this is the alternate hypothesis, okay, good. So in other words, we have the null and the alternate. And the differences between the two is the null always has an equal to, okay, in the statements, okay, but alternate does not. Very well. Okay, so this is how we write the statement. So we write this also as what? The alternate hypothesis, which will be H subscript A is such that, okay, because we are dealing with statements, use colors. Now, okay, so please follow the steps carefully. Don't mix them up. Don't mix them up. Step one is you have to write the given statement mathematically. So when we write it, this is step one. Mu is greater than 1000 charges. Step two is to write the contrary statement. Okay, so if you are given a statement, of course, if you conduct your research and it's false, then what will be the false statement? So it will be the opposite of what has been given. So that will be mu is less than or equal to 1000 charges. So that's step two. Then step three is to identify which one is null and which one is alternate. The null will have an equal to in it, okay? This second statement has an equal to, which is less than or equal to, so that is null. And the other statement, obviously, is the alternate hypothesis. Have I addressed your question for you, Richard? Richard, I'm waiting for your response. Okay, let's continue. So I think Richard will come back. Yeah, so that's it. Let's look at another example. Okay, on this same hypothesis, writing the hypothesis, step 1. Okay, so before we look at the next one, there is need for us to look at this table. Okay, so in this table, the table gives us a summary. So this is statement of null hypothesis. And then this is statement of alternate hypothesis. So write alternate. Okay, so these are all alternate. So sometimes instead of writing HA, okay, it might be written as what? H1. Okay, so you take note of that. So instead of writing HA, we might write it what? H1. But the standard notation is to use what? HA. Okay, the alternate hypothesis. So what we are saying is there are 3 different possibilities for each of the claims. If the claim made by the manufacturer, he's saying that the average is less than some value, this is how it will be written. Okay, good. So which means that then the opposite statement will be what? If he says it's less than some value, then the opposite will be greater than or equal. And as long as we have equal, that will be the null hypothesis. Now, if the manufacturer claims that mu average is greater than a certain value, like we just saw, then the opposite statement will be less than or what? Equal to. Okay, and because you have equal to, it is null. If the manufacturer claims that the average is not equal to means it can be less than and greater than, or less than or greater than, okay, but not equal to a certain specification. Okay, good. So when the manufacturer claims that, then the opposite statement will be what? It is equal to. Okay, good. And because it has the equal to, that becomes what? The null claim or the null hypothesis. I hope we are clear on this part. I hope you are clear on this slide. Okay. Now let's move on to the next point. So we have the second example here. This time, Kina Farmer is claiming that what is average. Okay, he says makes a claim that the new malaria treatments will cure patients in less than what? In less than 5 days. So on the average, okay, on the average, people will recover before what? The 5 days, okay? So an average of less than 5 days is a recovery time for their new malaria treatments. So we say that averagely, what Kina Farmer is saying is, averagely, patients will recover in less than what? 5 days. So that is a claim made by what? The manufacturer, which is now your objective to test in a research. Okay, that is becomes your objective to test in a research. So this is what? The claim. So that is step 1. Then step 2 is you have to write the opposite statement to this. So since the manufacturer says it's less than 5 days, your research should be looking at either greater or equal to 5 days. Good. Then the final step will be which one is the null and which one is the alternate. Now you realize that because the second statement has the equal to, that becomes a null. And then the first statement does not have equal to. So that becomes your alternate hypothesis. So let me use red here. So this is alternate hypothesis. This is null hypothesis. Yeah. Any question? Okay, Eugene says his battery will go off very soon. Let me take, I believe there are no questions since I'm not seeing any hands up. So let's move on to the next slide. So now that we've gone through our steps in the writing of the hypothesis, the next step will be Azuma now has his hand up. Sometimes I wonder why you keep so long. Okay, Azuma.
Yes, I thought you could have seen, checked from the chat because it looked like Savali was asking a question. That if a question asks, is that the way we should we can do it, or there's a different thing to that we have to work it if there's a question concerning this.
That's all you do. That is all you do to write your. Don't forget, this is just step one. Okay, so in step one, you write your null and your alternate hypothesis. Now we are going to step two, how to go about step two. Now, when we talk about step two, okay, step two is talking about what we refer to as your alpha, the significance level. Okay, when we talk about significance level, in every test, okay, we always have what we call as the confidence, the region of acceptance. Please listen carefully. So we have the region of acceptance. Okay, so this is acceptance. So this is the region of acceptance. And we also have the region of rejection when it comes to hypothesis testing. So in this form, this will reject the claim, or usually when we are testing, we test the null claim, okay, instead of just testing the claim by the researcher. You begin from the null, okay, and then when your null hypothesis falls so when your null hypothesis, okay, the given decision rule falls within this area, we say that we are rejecting. So these are rejection regions. So anytime your claim, okay, falls within the rejection region, we reject the null claim. Okay, so we have acceptance regions, and then we have the rejection region. Now, the maximum probability or the maximum allowable probability of rejecting a true null hypothesis is referred to as our alpha. The alpha, okay, we call it alpha. Okay, and then alpha is also called significance level. So that is the significance level. So significance. Okay, significance level. So our alpha is the what? The significant what? Level. Okay, so basically our alpha is the maximum allowed probability of rejecting what? A true null hypothesis. Now we'll be looking at details on how to go about utilize the alpha later in the example. Okay, but this is what I want you to know. Then again, in when solving examples, anytime alpha is always supposed to be given in a question, but when it is not given in the question, you make use of alpha of what? 0.05. 0.05 just means it's the same as what? 5%. 5% is 5 over 100. Okay. So when we say alpha of 5%, we mean alpha of 5 divided by 100, which will be alpha of 0.05. Okay, good. Now, if your alpha is 0.05, so in this case, if the rejection region is 0.05, which is 5%, then it means that the acceptance region will be what? 95%. Okay. Okay, so alpha is 5%.
Okay.